Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to find and graph the inverse of linear functions. All right, so let's go ahead and take a look at the steps that will be guiding our problem-solving process. All right, so the steps are as follows. Let's put it on the side. So steps for finding the inverse of linear functions, even functions in general. First of all, you switch x and y. Okay, and then the next step is you solve for y. When you're done solving for y, you're now going to rename your y, rename y as y inverse. Okay, in this problem, we're also going to be checking our work. And how you check your work is as follows. You graph the two functions that you found, y and y inverse. So graph y and y inverse, right? And they should be mirror images of each other over the line y equals x. Okay? All right, so let's take a look at example 1. Instructions are to find the inverse and verify by graphing. And verify your results by graphing. So let's say number 1, we have y equals negative 2x minus 4. Okay, so we're going to be applying the steps we just went over to this to find the inverse. So solutions is as follows. So we have the original function, y equals negative 2x minus 4. We're going to switch the x and the y's, okay? So your output y becomes your input x, minus 2, your input y, x becomes your output y, minus 4. All right, now we're going to solve this equation algebraically. It's a two-step process. We're going to add 4 and divide by negative 2. Okay, so let's start by adding 4. You add 4 to both sides. When you add 4 to both sides, let's see, you're going to have x plus 4 equals negative 2y. All right, finally, to isolate y, you just divide everything by negative 2. So divide by negative 2 every single term. And then your y result is going to be y equals. Remember, when you divide the same signs, it's always going to be plus. So you can just slash and dash this. That's a plus. Y equals negative. There's an invisible coefficient, 1 here. So we can write that as negative 1 over 2x. Whenever you divide different signs, your sign will be the difference, which is minus 2. Okay? So we switched x and y, solve for y. Now we're going to rename this y inverse. So y inverse is going to be negative 1 over 2x minus 2. All right? So to check our work, we're going to graph both of them on the same coordinate system. They should be mirror images of each other along the line y equals x, okay? So let's go ahead and graph them. So instead of our coordinate system, so let's start by graphing the mirror image first. So our mirror is y equals x. So if we write this in slope-intercept form, as y equals 1x plus 0. So our slope is going to be 1 over 1, rise 1, run 1, and our y-intercept will be 0. Okay? So we'll start from 0, rise 1, run 1, rise 1, run 1, rise 1, run 1. It's like a diagonal, right? Fall 1, back up 1, fall 1, back up 1. So there goes your mirror image, mirror line. We're going to use a dotted line for this one, okay? Reason being that this is not really the result. It's just a reflector right here, okay? So let's draw the line right down the diagonal like that. All right, so now what we're going to do next is we're going to graph the two functions and hope that their inverses, reflections, mirror images of each other over this mirror line right here, y equals x. Okay? All right, so the first one that we're going to do, let's call the first one, let's make it blue, okay? So the first one is y equals negative 2x minus 4. So for this one, if you look at y equals mx plus b, right? This is your m right here. This is m, and that's b. All right? So your slope is negative 2 over 1, which means that you're going to fall negative 2 and run 1, and then your b is where you begin at. B is negative 4. So you're going to begin at your y-intercept, which is 0, negative 4. Okay, so let's graph that. 1, 2, 3, 4. That's negative 4 right there. You drop 2 over 1. Or rise 2 back up 1. Okay, rise 2 back up 1. Rise 2 back up 1. And then we're going to draw our line right here. Let's make it slimmer. All right, so this is the line of the original function, y. Okay, so what we're going to graph now is we're going to go ahead and graph the inverse that we found. Okay. All right, so the inverse is y inverse. Let's put that in green. So y inverse is negative 1 over 2x minus 2. Okay. So for this one, m is the coefficient of x. This is m. Y equals mx plus b, and this is b. So our slope m is negative 1 over 2. Okay. We're going to fall 1 and run 2. We're going to begin at the b, which is negative 2. All right. So begin at 0, negative 2. So let's graph it. So starting at negative 0, negative 2, we're going to drop 1, run 1. Drop 1, run 2, sorry. Drop 1, run 2, or go up 1, back up 2. All right, go up 1, back up 2. So you have that straight line for your inverse. Okay, so let's go ahead and draw that. Make it a little bit slimmer. All right, so there goes our line right here. Okay, you notice that all three lines intersect. That's one thing that should always happen. Always, okay? They always intersect at a point. The function, the inverse, and the mirror line, y equals x, should always intersect at a point. And they should be y and y inverse. Oh, I call that y inverse. That's not y inverse. The blue one is y. So y and y inverse should be mirror images of each other along the reflection line. Okay, so along that reflection line, these two lines should be mirror images of one another. And that's the case here. Since they're mirror images of each other along the line y equals x, our result is correct. Okay, so let's write a concluding remark, conclusion. Since the two functions, the graph of the two functions are mirror images over y equals x, our result is correct. All right, okay, let's take a look at another example. So for number 2, let's say we have the function y equals negative 3 over 2x plus 6. Okay, so we're going to apply the same process in finding the inverse, and then we're going to verify if our results are in fact correct. So y, this is the original function. We're going to switch the x and the y's. X equals negative 3 over 2, y plus 6. All right, and now we're going to solve for solve for y. Switch x and y, solve for y. So to solve for y is a two-stepper, get rid of 6, and then negative 3 over 2. So to get rid of 6, we subtract 6 from both sides, subtract 6, subtract 6. When we execute that move, we are going to have x minus 6 is equal to negative 3 over 2y. To get y by itself, we can divide by negative 3 over 2, which will make it a mess. So to make it easier, we just multiply both sides by the reciprocal of the coefficient. Okay, so we multiply by negative 2 over 3, and then this entire thing multiply by negative 2 over 3. Okay, so this negative 2 over 3 on the left side will be distributed across these two terms. So we'll have negative 2 over 3x, and then minus times minus plus. 2 over 3 times 6 over 1. On the right side, these two cancel out, slash and dash. These two divide out, it's 1. And then minus times minus is plus. Okay, so we have y on the right side. So let's simplify this right here. 3 goes here 1, 3 goes here 2. So we have negative 2x plus 4 equals negative 2/3 x plus 4 equals y. Let's switch it around. Y equals negative 2 over 3x plus 4. And then rename it as the inverse. Okay, negative 2 over 3x plus 4. Okay, so let's go ahead and check our solutions by graphing. We're going to employ the same procedure that we used earlier. We're going to graph both of them on the same coordinate system. And we hope that their mirror images over the line y equals x, and that will be that. So let's start by graphing our mirror line. So the mirror is y equals x. Okay, in slope-intercept form, that's y equals 1x, invisible coefficient plus 0. So this is our m, and this is b. All right, so m is going to be 1 over 1. We're going to rise 1, run 1. And then we're going to begin at 0, 0. Begin at 0, 0. Okay, so 0, 0. Rise 1, 1, 1. Rise 1, 1, 1. Rise 1. So just go down the diagonal, right, like that. Okay, so what we're going to do is we're going to draw that line as a dotted line. Let's make it red and skinnier. All right, so we're going to draw it as a dotted line. Like that. Okay, and then let's graph the two functions. All right, so the first one that we have is y equals, let's put that in blue, y equals the first one, negative 3 over 2 x plus 6. So m is the slope, b is the y-intercept. All right, so slope m is negative 3 over 2. So we're going to fall 3 and run 2. We're going to begin at 6. That's our y-intercept. Begin at 0, 6. Okay, because it's a y-intercept. All right, let's graph it. So starting at 0, 6, 1, 2, 3, 4, 5, 6. All right. We're going to fall 3, 1, 2, 3 over 1, 2. Fall 3, 1, 2, 3 over 1, 2. Okay, let's go ahead and draw our line of the original function. Right there. All right, there you have it. Okay. All right, so what we're going to do next is we're going to draw the graph of our inverse function. So let's do that. Let's put that in green. The inverse function, y inverse, that we got is negative 2/3 x plus 4. So the slope is negative 2 over 3, which means we're going to fall 2 and run 1. All right, and our y-intercept b is 4, so we're going to begin at the y-intercept 0, 4. Okay, 1, 2, 3, 4. All right, that's our y-intercept. So we're going to fall 1, we're going to fall 1, 2, and go over 1, 2, 3. Fall 2, 1, 2 over 1, 2, 3. Or we can rise 2, 1, 2, and back up 1, 2, 3. All right, go ahead and draw the line. Of the inverse through the points we just graphed. Right there. Okay. And you can clearly see that they are a reflection of each other over the line y equals x. Okay, so let's go ahead and label them. This is y inverse right here, the green one, and this is y, and this is the mirror image, y equals x. See that they're mirror images of each other. All right, so let's write our conclusion. Since the graph of the functions, are what? Since they are mirror images, over y equals x, they are inverses. All right, and our solution is in fact correct. So that's that. Thanks so much for taking the time to watch this presentation. Also, a special thank you to all our supporters who like, subscribe, and comment on our videos. Support resources can be found at mathgotserved.com to check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.